giant insects, tiny mammoths, and whales that used to be small on land. In the story of size, expectation gets turned upside down. Rats are the heroes. Ants are the kings. And people are getting bigger all the time.
People will probably be 7 or maybe even 8 feet tall.
Size matters, right now on Evolve. What if there were a world where the big creatures were small and the small creatures were big? In fact, we're living in it. The sizes of different animals seems fixed, but in the long view of evolutionary time, they are ever-changing and full of surprises. The world's most massive land animal today is the African savanna elephant. The biggest was 13 feet tall at the shoulder and 24,000 pounds. Far smaller, of course, are the tiny ants scampering underfoot, weighing in at 1/1000th of an ounce. The elephants outweigh the ants, right? Wrong.
Biomass is the sum total of the weight of a group of animals or plants. What's amazing is that the biomass of ants makes up 20% of the biomass of all other animals on the land, even though each individual ant is tiny.
In fact, ants outweigh elephants by more than 10 to 1. Elephants, 3 million tons. Ants, 33 million tons. Weight, length, height. Nothing is fixed. Nothing is certain. Size changes because size can determine an animal's fate.
Fundamentally, for animals, size matters. It makes a difference to every interaction you have with other organisms, and it makes a difference to the way you live in your environment. It affects how much you need to feed, it affects what you can feed on, and it affects what's going to feed on you. Everything depends on size.
The story of size is an unending series of outlandish science fiction tales. Bugs as big as birds, elephant relatives as small as ponies. The only difference is these stories are scientific fact.
I would love to have a house mammoth.
Pygmy mammoths, relatives of elephants, evolved on the Channel Islands off of California. Paleontologist Larry Agenbrod was the first to identify these full-grown but tiny mammoths back in 1994.
Got a phone call from Channel Islands National Park, and they explained they had a big skeleton being exposed on the island. Could I determine whether it was a mammoth or something else?
Mammoths emerged about 1.8 million years ago, and some species were alive as recently as 4,000 years ago. Mammoths were larger than modern-day elephants, up to 14 feet at the shoulder. What Agenbrod found on the island that day was strangely smaller. At the Mammoth Site Museum in Hot Springs, South Dakota, Agenbrod compares his beasts.
Here's a femur of another mammoth. It's the same femur as we got there, a right femur, but you can see that it's very small, only a fraction of the size of this big Columbian mammoth.
A study of the wear and tear on the bones determined that the smaller animal was not a juvenile. It was a fully grown adult. Years of digging since that first find have revealed that an entire community of pygmy mammoths evolved on the island.
On the island, I'm finding the average size about 5.5 feet.
These mammoths were 1/10 the weight and half the height of their cousins on the mainland, and lived there as recently as 20,000 years ago. Why did the mammoths evolve to be so small? Agenbrod knew the environment played a role, and that strange things happen to an animal's size on islands. On the Galapagos Islands in the Pacific Ocean, tortoises can balloon to 700 pounds, 3.5 times continental size. Indonesia's Komodo Island is home to the world's largest lizard, the 10-foot Komodo dragon. These giants thrive, cut off from predators. So why would a mammoth shrink? Agenbrod looked to the island history for clues. He discovered that over time, sea levels rose. And what was one large island with a broad coast became 3 smaller islands of steep and craggy peaks. To survive, the huge mammoths would have to find grass to eat higher and higher on the steep slopes of the island's interior. And for that task, being big was a huge disadvantage. Like a poorly designed SUV, their center of gravity was too high.
I put these specimens on slopes and find that the continental mammoth could only handle about 20 to 25 degrees, whereas the pygmy mammoth was comfortable with up to 35-degree slope.
Over many years, the big mammoths died out. The smaller ones survived, mated, and bred generations still smaller, until the pygmy was all that was left.
In evolutionary terms, we're looking at adaptation. So the island selects for a smaller animal capable of getting to upland pastures.
Like all animals on Earth, the size of pygmy mammoths was determined by a complex cocktail of factors. Here on this island, food supply and the lay of the land were enough to shrink them to 1/10 of their original mass. They were able to adapt and survive until humans arrived on the scene.
So I think these little beasts saw the first people arrive on the island, and the first people that arrived on the island saw a meat source that was manageable. I kind of regret the fact that we didn't have an island where nobody ever got to. They were still on Wrangel Island 3,700 years ago. That's when the Egyptians were piling rocks and make pyramids.
Agenbrod holds out hope that even though humans were a major factor in their demise, someday humans might engineer the mammoth's return.
I'm for cloning if we can bring back a mammoth. I see no reason not to bring them back if we have the skill and the technology to do so.